Hello everyone, welcome to my channel again. I am Cherry, and today I want to solve two legal questions. And yes, I just finished this question and I beat 99% of users with Python 3. So this is a huge milestone, or this is a huge achievement. So I just want to show to you. Yeah. Okay. So let's return to the question description and let's solve this question together. Okay. So this is a very classical question, and we need to construct a binary tree from preorder and inorder traversal. So we are given two arrays. The first array is preorder, the second array is inorder, and the preorder is to traverse through the tree by checking the left and the middle and then the right nodes, right? So I think most people must know this, so I'm not going to explain what is preorder or inorder, and I'm not going to explain these concepts. So let's so first of all, let me tell you the idea of solving this question. Yeah. So actually, if we want to construct a tree from these two arrays, first you need to, let's see, currently we are picking this number, which is 3, and because preorder, we will check the root of the tree first, and then we will check the left nodes and then the right nodes. So this is 3, then 9, 9 is in its left nodes, and then the right nodes, 20, 15, 15 and 7, right? So 3 is the root of the tree, and because in our inorder array, we traverse through the tree by first checking the first checking the left node. So 9 will be at the left, on the left of the 3, which is the root of the tree, right? So if we check the currently 3, then we go to the we go to check the 3 in our inorder array. We will find that this 3 split the array into two parts, right? So the left part is 9, and the right part contains 15, 20, and 7. So yeah, so that means currently we create a new node, which is 3, and let me currently we pick the 3, the number 3, right? We create a node with the value 3, and then we will split the array into two parts. The first part is the first part is 9, because 3 here will split this array into two parts. The first part is 9, the second part is 15 and 20 and 7, right? And yeah, and we also know that the length of the left part and the length of the right part, the length of the nodes in the right part. The left is 1, the right is the length of the right nodes, or is 3, right? It's 3. So that means we also get wait a minute, this is in order, okay? This is in order. We split into two separated array. And we also can get the length of the left tree and the length or the size of the right tree. This is 1, this is 3, and according to this size, we can separate the remaining preorder array into 2 parts, right? Because the size of the left tree is 1, so our preorder, let me see, is 9. Our the right part is 20, 15, and 7. Yes, so that means we divide one problem into 2 sub-problems, right? So we can continue our tree building process according to these 2 arrays and also these 2 arrays. We will consider building tree separately, because we have already created the node 3, and then we also know that on the left side or on the left tree subtree we will have 9, right? We will have 9, and on the right side we will have 15, 20, and 7, and then we will continue constructing subtree according to these 2 array, right? This is Inorder, this is Preorder. Then we will make 3 the node 3, make its 2 left and right pointers point to the subtree, right? So this is the solution. I hope I have already explained clearly. Yes, so let's start coding. Okay. Oh, this time I forget to okay, it doesn't matter. So like I said, oh my god, like I said, I will use the first element of the preorder to create a new node, and then I will get the position of these 3 in order. We will get the index, the index of 3, so that we can get the length of our left subtree and the length of the right subtree. So that means we need an auxiliary hash map to help us store the position of each element in our Inorder array. So let's create a hash map initialized as an empty hash map, and then I will traverse, or I will iterate through the Inorder array to get the position of each element in this array. So enumerate. Okay, I think enumerate in order. This is in order, and then I will keep the position of each value in order array. Yes, then I will create a function to build our tree. So in our function we will have 4 parameters. These 4 parameters indicates the position, or the starting or ending, the beginning or the final position of our preorder and Inorder array. So we'll use start 1 and end 1 to indicate the range of our preorder. And then we will use S2 and N2 to indicate the range of our in-order array. And then if currently our wait a minute, if the beginning index is larger than our final index, that means we don't have any element that can be used to build our tree. So we just need to return. Then I will use the first element of in our preorder to create a new tree node, right? Tree node. I will use the first element in our preorder. The first element, yes, S1 indicated the first element of our preorder. You need to know that this preorder will change the preorder. Okay, doesn't matter. Let's continue. Then I will get the index of this element, the index of this element in our in-order array. We'll get the position of this element in order array. So I'll use hash map to get the position of this element. Okay, and then we can get our size of both tree. We'll get the size of our left tree and right tree. So left sides will be, I think it's index minus S2, right? S2 is the element of our first element. S2 is the index of our first element in our in-order array. Okay. Here in-order array will change. In the first time it is the complete array, and when we create our first node, the in-order array will become 9, and another is 15, 20, and 7. So I hope you can understand what it means. Yeah, our right sides will be E2 minus index. Okay, then the node we created, and we need to make its left tree to be built, right? Yes, how to do that? I will change. Okay, let's see this 3, and then the left tree will be constructed by using these two array, 9 and 9. Okay, this is the array. Let's make it more clear that this is okay. So in our previous, we need to update our S1 and E1 indices. So I think the S1 will be updated by adding 1 to the S1, right? So S1 plus 1, this will be our new, and the E1 here, E1 also is the index of 9. So here I think it is S1 plus 1, and plus L size minus 1. Yeah. So if you don't understand what this means, you can just try to do the calculation on your own, and you will definitely understand what this means. Yeah, I just want to get the range of this subarray. Okay, even though it only contains one element, but it is also a subarray. Okay, so I will write the following index. Okay, the right subtree will be built by like this. So this will be S1 plus L size plus 1, and there will be E1 and index plus 1 and E2. So this is how we construct our subtree. Yeah, just by updating these 4 index, or just by rearranging the range, the range of our preorder and inorder array. Yeah. So I just return the node. So let's call the function. First, let me get the size of our tree, and then I will return our tree. Okay, this one. So this is the solution. Let's check if it's correct. Okay. Oh, seems I made some mistakes. Let me check. Let me check where I am make mistake. Oh, here. Look at this. Okay, if S1 is greater than E1, that means we don't contain any numbers in our preorder or inorder array, right? So that means we don't need to build a node. We don't need to build node. So let's try again. Okay, let's submit our result. Yes. So this is the solution of this question. Hopefully you will understand. Sorry for my awful English. I am keep working on that. So if you have any question, feel free to ask me, and welcome to. I will be very happy if you can leave your comments or suggestions. See you. Bye.